acid and basic acidity and basicity trends, which pretty much always most of the students have the trouble with. All you gotta do is understand the concept first. So acid, he's gonna give you two acids or two bases to compare. So the first thing that you do is decide what you have. You have acid or you have base. Then what he tells it is he tells you to create the change and evaluate. So if it's acid, acids like to lose a proton, so do that and then evaluate the conjugate bases of that acid. If you're given bases, bases like to grab one hydrogen, so add a hydrogen and then evaluate your conjugate acids. So you have to understand the relation between conjugate acid and the base, and conjugate base and the acids. So there are 4 protocols that you need to know. Of course, there is a handout for these videos, so make sure you print that out. It has a little bit of explanation first and then a bunch of practice problems, which I have found very helpful, and a lot of students have told me it helps a lot, because those are the kind of questions he asks on the exam. So it's thinking, it involves thinking. Okay, so there are 4 protocols that you have to follow. So the first one is size, second one is electronegativity, third is resonance, and number 4 is inductive effect. Alright, these protocols are already on your handout, so you don't need to write it again. Just follow the order. So if he gives you something, first thing that should come up in your mind is, can I use size protocol? If not, move on to the next one. Can I use electronegativity protocol? If that's not even possible, then move on to the next one, which is resonance, and the one after that, which is inductive effect. The first 2 are quite easy, so I see use of the last 2 protocols a lot more than the other 2 on the exams. Alright, so let's talk about size and electronegativity. Is pretty straightforward. There is a trend in your periodic table, which you should have known from Gen Chem. Now, resonance is something that you have already learned, but we have a false rule about resonance. So let's clear that out first. So when you have, let's say you're comparing 2 structures, and one structure has resonance, the other structure does not have resonance. In that case, resonance will win. So the structure that has resonance provides more stability, so it's more stable, so it's weaker, whatever, so stronger, the opposite of that. Alright, then if I have 2 structures in that both of the structures have resonance, then you have to evaluate the quality of the resonance, not the quantity. Because anytime you have a benzene and something attached onto benzene, you'll at least have 4 different resonance structures. But sometimes 4 versus 2, you may think that more resonance is better than less resonance, but that's not always true. You have to evaluate the quality of those resonance. Which resonance are more stable than the others? So that will give you the answer. The one with more stable, even if there are less number of resonance, they might still win sometimes. And after you do the practice, you'll understand what I'm talking about. You will come across these 2 circumstances, and you have to pick according to what I said. Alright, and the last one is neighboring effect. So 2 things that could come up. You may delocalize the electron cloud, or you may localize the electron cloud. Whenever you're delocalizing electron cloud, you're making the structure more stable because your electron charge is as spread as possible. But when you're localizing something, you're actually adding or donating towards the electron cloud, and in that case, your structure will be less stable, and you answer according to that. Now, anything that I said so far, it involves stability, so you have to realize what is the relation between stability and the strength of the acids or bases? For that, look at the next section where I have a bunch of terminology. Alright, so let's talk about that real quick. You have 6 different terms, and I want you to circle which one of those terms mean that my acid will be stronger. So for this, please pause the video for a second and try to do this on your own, and then start again and I'll explain you what it means. Alright, please pause it. Okay, so after you're done evaluating that, okay, maybe this is more acidic or less acidic. Now you learned 2 terms in Gen Chem, Ka values and pKa values. pKa is P means it's negative log of that value. Alright, so that's what the P stands for. Now, higher the Ka, the better acid, or the stronger the acid. So higher the Ka value, stronger the acid. Now pKa is negative log of your Ka. So that means lower pKa will mean stronger acid. Alright, so that's the terminology for Ka and pKa. Now, about the more stable and less stable conjugate bases. So in that case, think about the HCl example that you all obviously know by now. HCl plus water goes to Cl minus and H3O plus. This reaction, you know your acid is super duper strong. It's one of the strongest acid. So this reaction happens to pretty much 100% completion. Alright, this reaction happens because you're going from stronger something to weaker something. So this is your acid, that's your base. That means this is your conjugate base, and this is your conjugate acid. Always compare acids with acids, bases with bases. So I will compare acids with acid, bases with bases. Alright, then we know that this is stronger acid than H3O plus. Alright, so this is stronger. Now water versus Cl minus. What's more stable? Water is stronger. So it's stronger base, and Cl minus is weaker base because it's so stable with that negative charge. It gets the octet, it gets the configuration of a noble gas, and because of its size, it's a very good leaving group as well. So you should know that it has to be something stable for it to be a very good leaving group. Alright, so now that we know, we found out the strength of the acids and base for this equation, you can always keep this in mind. This is your acid. This acid reacts with this water because the conjugate base you're making is more stable. So this is more stable conjugate base. That means it's a weaker conjugate base. And when you have weaker conjugate bases, the acid that it came from has to be stronger acid. So that's the relation between these two. Always think about HCl and water example if you forget what's the relation between conjugate base and acids. So the third term that means stronger acid is the last term, which is more stable conjugate base will give me stronger acid. Alright, so keep in mind, he can ask you this various different ways. He'll give you any one of this 6 terms actually, and you have to evaluate what is he asking for. You need to bring it down to the simplest form, which is more acidic or less acidic. Alright, so I hope this terminology is clear because he will ask you different terms when you're answering the question. Alright, so after we're okay with all the terminologies for acid-base, the next thing is practicing the problems that I have. I have about 11 problems on there, and I'll go over every single one of them. So I'm going to end this video here. Just try to practice them. First, attempt each of the acid-base problem, and then watch the video just to see the solution. And always watch the video because your thinking, you may get the right answer, but your thinking process after that could be wrong. So always watch the video just to see the reasoning is right or wrong. Alright.
The Teaching Center, UF's Learning Resource Center.